I'm sharing my
Oh,
screen.
just wait for a moment, Ritu. Let's start with the introduction part, then we're gonna show that one. Okay.
Okay.
Yeah. So we are live, I guess, Mother. Okay. So yeah, hello everyone. Good afternoon, guys. Welcome to our YouTube session today, and where we will be exploring some proven tips and techniques into the topic that how you can optimize your UI with Jetpack Compose. And this time we are having our speaker, Ritu Chakravarti, a very young and talented, India's first Google Dev expert at Kotlin. So before we begin, first of all, Ritu, thank you so much for accepting our invitation and enlightening us with your valuable insights and tips. Review, am I audible to you?
Yes.
Okay. So before we get started, would you like to tell a little bit more about yourself to our audience?
Sure. Yeah, I am Rivu Chakraborty. I am a jury for Kotlin, which is a language by JetBrains and which is hugely popular among Android developers. Uh, it is also used in backend and other platforms. But yeah, I am working in the industry for more than a decade now. Currently, I am with Viacom 18 or Geo Cinema. My previous engagements include Byju's, Paytm, Gojek, Misho, and various other companies. Right. Throughout my career, I worked with startups. Uh, I wrote multiple books on Kotlin and Android development. Currently, writing one,
Oh,
and
that's
I
impressive.
am yeah. I am an active person in community, so I try to attend meetups and events around Android development whenever it happens around my area. Sometimes I organize them, and sometimes I give a talk at those meetups and events, just like what I'm doing right now. And I have started a YouTube channel,
Yeah.
mostly talking about tech and tech community.
Okay.
So yeah, I am yet to regularly publish videos on that channel, but yeah, you can probably check it out. And yeah, that's most of the stuff about me.
I guess that's very impressive, and you are doing a really great job in this community as a Google Dev expert and Kotlin field. So before we get started, without making a delay, so we are good to go with the presentation. All stage is yours. So yeah,
Thank
you
you.
can start now
I
with the
hope my
presentation.
screen is visible.
Not now.
Okay, let me try. Visible now.
Yeah, now it says. Yeah, now it says. Well.
Uh, so I'm sharing now. How to actually? Okay, I don't know how to actually present instead of this layout. Uh,
No worries. No
I
worries at all.
presenting in Meet after a long time. So yeah, we'll go
Okay.
with that.
Sure, sure, sure.
Uh, so yeah, today we are going to be talking about optimizing UI in Jetpack Compose.
Yeah.
I already gave my introduction. So yeah, now let's get started. Let's start understanding with what is composable, right?
Yeah.
So composable is not an annotation processor. Many people believe that composable is an annotation processor. It's not. It's rather is a keyword that works closely like how suspend works, right? How suspend works in coroutine. It's more close to that. Uh, Now, to understand how composable works, let's take an example. Right, see, here I have a composable function blue text, which just renders a text and with color blue, right? And how that is actually represented after the compilation. So, compiler actually injects something called composer or replaces either composable with composer parameter in the function. Composer starts, it renders the text, and then composer ends. Right, that's how it generally works. Uh, if you have recomposition enabled screen, if you have something that recompose, then yeah, this is how it's it's represented in memory. So composer starts, something happens. Here recomposer state is going on, and composer ends. When recomposition is needed, it will basically recompose the entire column, right? Uh, Now, what is composer? Composer is a culling context. Similarly, how deferred context is with coroutines, right? It contains a data structure that closely resembles gap buffer that actually enables composer to recompose various stuff. So whenever this text this text that gets stored in the gap buffer, and whenever recomposition is needed, the composer uh, tracks the difference, and the delta is rendered in the memory again and stored in memory. Sorry, rendered in the screen again and stored in memory. So yeah, now what is recomposition? So think of recomposition as recursion, right? So when we use function recursion, the same function is called again and again until there's an exit condition. Think of recomposition with as recursion only, but with update parameters. So every time recomposition happens, something change. That's why recomposition is happening, and probably a state value changed. That's why recomposition is happening. So it will call the function again here. You can see how it actually works. So it will call the function again, and here it will update the scope. So next time recomposition happens, it will be like this with the next composer. Right. Now let's try to understand how to break down composables. So let's uh, try to design this screen, right? It's a very simple and straightforward screen. We have a profile photo, we have a name, we have a location, two buttons, and a list. Now, if I put everything together in a composer function, it will look like this. I know you can't read it. It's I don't want people to read it and copy. So yeah, if you put everything together, it will look like this. It's a pretty much overloaded composer function, and the issue with this is not only it is a big function and like tough to maintain. The issue is that it manages several states as well. So with that, managing recomposition becomes really difficult. So what we need to do, we need to break it down. So instead of that, we create a profile screen where only the um, uh, for the entire screen, and inside the profile screen we have a profile section and I post. So if you go back to the screen, so this is the profile section, and below this is the post section. So we divided the entire screen into these two sections, and then post section is just items. There is nothing new. It's similar like what we did here, but profile section is here. So here we instead of again putting everything together, we have the profile photo here. Sorry, yeah, we have a profile photo here, which I further broke down to a different composable altogether. Text we are keeping it as it is, and here what I know you can't probably see it, but here what we were doing is that we were using material typography, material dot theme dot typography dot body, body one, body two, like this here. Instead of that, we are using our own constant references. So you should create your own typography object, and these will be constant. So not much recomposition will happen when you use them. And for follow button uh, and message button, I again created separate composables. Now that's about breaking down composables. Now let's understand what a state is. So this is a data class, right? Where probably you are building a movie list app, and that's how you create a state where there are queries, there are list of movies, error or success. loading state, and if someone clicks the details, some bottom sheet comes up with movie details. So yeah, details state. And if you want to keep search history, that also is there, right? So this is a simple data class. And probably you are using live data or state flow, something like that, right? So that's how you basically create a state from the data class and observe it. So state is basically what is in the UI that should be represented, or rather we can say UI is a representation of the state. So whenever your state changes, Compose, if you are using the APIs by Compose, for example, the state, mutable state or state, then delegates, then uh, whenever your state changes, Compose notifies the composer, and your UI is recomposed, just like what we learned in last section, right? And yeah, that triggers a decomposition. Now uh, if you are here, we are basically talking about optimizing it, right? So on optimizing, you probably know what is stated, but what you should know is that where to keep the state. So there is a term called state hoisting. It's just a fancy term. What it actually means is that where should you keep the state. So if your what it is written here is that if your UI or your composable is a very simple one, then you don't always need to hoist the state, or state hoisting means keeping the state to some other composable and passing it, right? You don't really need to do that in most of the cases. As we talked about earlier, you should break down your composables, and if you break down your composables, then most of your composables will be simple enough. In most of the cases, what we'll do is like this. You will keep the state to yourself. So here, the swipe refresh state, this is not called state hoisting because this show list function is holding this swipe refresh state and managing it by itself, right? But within this function, if you look at this box, then yeah, this show list function is hoisting this swipe refresh state for this box, or this for this modifier. So yeah, and here's another example. So we have a form screen. You are probably building a form application. Then you need to create a form screen, right? And yeah, then I have this query where anyone adds a new item, this query will be updated. And whenever this query is updated, I am launching a launch effect. We'll talk about launch effect later, but yeah, uh, I'm doing something. So this launch effect will actually listen for this thing to change, and whenever it's changed, it will do something here. Now, this is not being hoisted. So whenever something changes in the form, I am actually updating it through a lambda. However, this state where by view model, this we are passing it down to the my form composable, right? So this state is being hoisted. So both the ways are presented here. Now we saw launched effect. Now let's understand what this is. So all these are called side effects. And here's a definition of side effect. You can find it in compose.dev or android.dev/compose. I have linked it in the resources section, so you can find it. So basically, in your composable, whenever something changes, you update the UI, right? Now there would be some times when something is changed and you need to call an API, or for example this pull to refresh as well, right? Whenever that pull to refresh state is changed, you need to call an API. So that is one example. Another example was the form one I showed you. So whenever that query changed, you need to call an API. So for those, you use side effects. or effects basically. So launched effect is one type of effect where I'm again using the query one only. So as you can see here, when the query one was changed, we saw that something was called inside. So what we are doing inside is that we are checking if it's blank, then we don't need to do anything. If it is not blank, we are adding a debounce of 500 milliseconds. That means that we'll wait 500 milliseconds before calling this view model function. Why? So within 500 milliseconds, user can type something more, right? So we are after user has done typing, will this will be triggered after 500 milliseconds, and whatever user typed last, that will be taken, not all of them. So yeah, this adds a debounce effect, and we are calling this function with launched effect. So this is one type of effect. Another type of effect is disposable effect, which you can see here. So in this screen, whenever the screen is loaded, we are basically calling an API and getting all the data, right? We are loading the items. Now, uh, what we want is that probably the screen is loaded and user press back at the same moment. So before the items are loaded, user press back. So I don't want to continue with loading the items, right? I want to cancel the loading. So in that case, we can reference the job. Now in launched effect, we don't know when the screen is being disposed of. In disposable effect, we know. So on disposed will be called when the screen is no longer in the view. So in that case, we can call job.cancel. So this works. This structure is similar to how we used to do on activity on destroy. For most of the cases, you don't need it, but yeah, if you need it, you can use disposable effect. Uh, why you don't need it? Because if you are using view model properly, then for most of the times, view model takes care of life cycle, and you don't actually need disposable effect. But yeah, if you have something, right, for example, you are observing a life cycle, and when the screen is gone, you want to dispose the life cycle observer. So that also you can do here. uh, there's another thing called side effect. This is for when you don't want a key. So launched effect and disposed effect, these will only be called when something is changed, right? Launched effect will be called when we first enter the screen once, and then every time add item query is changed, it will be called. Dispose effect, since I am using unit as a key, it will be only called when this function is first called, and until composer is invalid. So what happens is that if its parent composable is recomposed, then this composer for this composable might get invalid. So in that case, disposable effect will be called again. Otherwise, no matter how many times this screen gets recomposed, disposable effect will only be called once. So yeah, but side effect is different. It doesn't take any key. It gets called all the time. So it's pretty much similar if you put it outside without using side effect. What will happen, and inside side effect it will be the same. But what happens with side effect is that it makes a good structure. So here it's an example from Android.dev site only, where they demonstrated how to use side effect. So here, whenever the user changes, uh, this function is getting called, and every time we want to set the user property properly, right? So that's why whenever this function is called, we want to make sure this is set. So that's why we are using side effect. Now, remember. So remember actually lets you remember a state, right? If you are using mutable state within a composable, you are using remember as well. Now, remember has a very good user optimization as well. For example, this list, right, that we are sorting here. So and before showing, we are sorting the list here. What happens when this function gets recomposed? This list will be sorted again, although we don't want that, right? So probably some item in the list got updated, and we want this function to recompose, but we don't want to sort it again. because we already have a sorted list. So in that case, we can use remember in this way. So we can put the sorting mechanism inside remember and mutable. Sorry, we can put the sorting mechanism inside remember and mutable state of, and then if the function gets recomposed, this sorting will not be done again unless the list is itself has changed, right? Again, remember takes a key. It's an optional. So if you want to remember something unconditionally, you don't need to use the key. But if you want this block to be executed every time this key is changed, then you can use a key. Then comes stable and immutable annotations. So, stable is used to communicate when to some guarantee to Compose compiler that if a value is changed within this class, it will notify the Compose compiler, right? So, what happens without stable and immutable? So, every if you have a var, then composable recomposes pretty much a lot, right? And that can affect performance. So sometimes you want the recomposition, sometimes you don't want, right? So stable and immutable, let's say control that. So stable shows a guarantee to compose compiler that if something is changed, I will notify you. And what does immutable do? Immutable tells that nothing will change in this data type. This is an example of immutable. So whenever you have a state class with all vals, right, you can annotate that with immutable. And what do you do when you need to change something? You basically copy this class, copy this state, create a new state, and then set it to the state variable. So compose is notified through state, not through any change within this class, right? Now, sometimes you want to notify compose from this class. So in that case, you can use this. So this will not change. This will change. So instead of relying on the variable, what we are doing is that we are using stable annotation and we are using mutable state of within itself. So if background color is changed, we only the portion which is observing the background color will be recomposed, not the whole composable. So that optimization is provided by stable. Uh, Now comes immutable list. So lists are pretty much unstable. So whenever you are using a list, and if you scroll around, you will notice that. So I have a video on that as well on my YouTube channel. Please go and see that. So if you scroll around, you will, and if you observe the recomposition, you will see every item is getting recomposed again and again and again. uh, how to avoid that? Using an immutable list. So it will let compose compiler know that hey, this list has not changed, right? So compose will not recompose again and again. Rather, it will render the already available composable in the memory. So how to use that? You actually have to use a dependency, that party dependency, Kotlin JetBrains immutable list. You can search about it and you will find it. And the next thing is that any list. So we are already using it here. You probably didn't notice. So any list that you have, right? So this sorting will put out a list, right? After that, you put dot immutable list. So that's how your immutable list is created. And yeah, that's where I will wrap up today. Uh, Please go and see my videos here. And these are some resources you can go and check out. I have shared the slide viewable link with the organizers, so they can probably put it in the description. And yeah, that's it. Thank you. I can take questions now.
Okay, that's great, really. That was a great presentation that you have shared. And yeah, definitely we will share your presentation with that document link basically that you have shared with us. So we will share
I
in
will
that
actually
community.
share a speaker deck link, a PDF version. You can probably link
Yeah.
that.
Okay, no worries at all. So there is one question from users end basically. So, like, he's asking that can we use Jetpack Compose? I mean, he's asking, can we use Jetpack Compose to work seamlessly with the existing Android code bases?
Yes, you
So,
can.
can you explain him like how you can use some kind of?
So Jetpack Compose is kind of backward compatible, right? You can use Compose view to render
Okay.
Compose inside current XML. Similarly, if you have a screen in Compose and you want to render some XML, you can use Android View inside Compose. So Compose View and Android View, these are your tools to achieve backward compatibility. However, let me be clear that Compose View within a list has performance issues. So when you are inside a list, try to not use Compose View there. Rather, convert the entire list, including the adapters, to Compose. That way, you will have an optimized code base as well, and you don't need to manage adapters, view holders, and all those things. Since in Compose it's pretty much easy and straightforward, so it will be
Okay.
easier to manage. So yeah, my suggestion would be avoid putting Compose View inside list. There were significant bugs that are resolved now, but still it's not very performant to put a Compose View inside a recycler view.
Okay. Okay. So, I guess he has got your answer. Another question is like, can you mention some pre-built components so that we can add some animations, some transitions? Can you mention those some names?
uh, I, I
Pre-built about pre-built components.
uh, I didn't get the question. Can you repeat it?
He is asking, can you mention some pre-built components
Uh,
for adding transitions, animation, and such effects?
so Compose has a lot of APIs. So if you search online, you will get all the APIs. And other than that, if you want to use Lottie, right, that is also
Yeah.
available. Lottie supports Jetpack Compose.
Okay, that's great. Okay, so there is no other question than this. And I guess we have limited time frame as well. And we are really thankful for your time, Divi, that you have
Thank
shared
you.
your time and sharing that PPT and enlightening us with your valuable insights. So yeah, once again, thank you for being a part of our community, and we will make sure we will drop your link in the description as well as in our Discord server as
Sure.
well.
Thank you.
So yeah, guys, that's all for today. And if you enjoy this session, don't forget to like the button and turn on the notifications so that you don't miss any our upcoming event. So yeah, thank you guys. Thank you, Devi.
Thank you.
Bye
Bye.
bye.